What does it take to put a human being on the moon? Not just to reach it, not just to fly past it, to land there, step outside, and come back alive. For most of human history, the moon was untouchable. It was a light in the sky, a symbol, a mystery. Then, in one of the most daring moments ever attempted by mankind, Apollo 11 turned that mystery into a landing site. And the story of how it happened is even more incredible than the landing itself. Because this was never just about planting a flag. It was about proving something far bigger. Could people build machines precise enough to cross 240,000 miles of space? Could they survive the journey? Could they trust a computer with their lives? And could they do it before time ran out in the Cold War race to space? To understand the moon landing, you have to go back to the race that made it possible. In the 1950s and 1960s, the United States and the Soviet Union were locked in fierce competition. Each side wanted to show the world that its science, its industry, and its future were stronger. The Soviets struck first with Sputnik, the first artificial satellite. Then came more Soviet firsts, the first living creature in orbit, the first human in space. The pressure on America grew fast, and then President John F. Kennedy made a bold promise. Before the decade was over, the United States would land a man on the moon and bring him safely home. At the time, that sounded almost impossible. Think about what had to happen. A rocket had to lift off with enough power to escape Earth. A spacecraft had to travel through space with extreme accuracy. The astronauts had to navigate, communicate, survive temperature changes, and land on another world. Then they had to leave again, meet up with another spacecraft in orbit, and make the long trip back. No one had ever done anything close to that. But the Apollo program began to turn imagination into engineering. Thousands of people worked on it. Engineers, scientists, mechanics, programmers, test pilots. Every piece had to be tested, improved, tested again, and trusted with human lives. The Saturn V rocket became the giant that would carry Apollo missions beyond Earth. It remains one of the most powerful rockets ever built. And inside the spacecraft was another miracle of the time, a small onboard computer. By modern standards, it was incredibly limited. Yet it helped guide the mission with calculations no human could perform fast enough in the middle of flight. That tiny computer, along with ground control on Earth, helped make the impossible manageable. Then came Apollo 11. On July 16, 1969, Neil Armstrong, Buzz Aldrin, and Michael Collins launched from Florida. Armstrong and Aldrin would become the first humans to land on the moon. Collins would remain in orbit, alone, waiting for their return. 3 men, 1 mission, and no room for error. The trip itself was a test of nerves. They crossed the silence of space and entered lunar orbit. Then came the most dangerous part of all, the landing. The lunar module, named Eagle, separated from the command ship and began its descent. But the moon was not the easy, flat place some people imagined. As Eagle came down, alarms began to appear. The computer was overloaded. Fuel was running low. The landing zone was filled with rocks. For a few terrible moments, everything depended on fast decisions. Neil Armstrong took manual control. He had to steer past danger while watching the fuel drain away. Mission Control on Earth watched in suspense. The numbers were getting tight, very tight, and then finally the words came. Houston, Tranquility Base here. The Eagle has landed. For a moment, the entire world seemed to hold its breath. But the story was not finished. The real question was still waiting. Would they step outside? Would the mission succeed beyond the landing? And what would a human being actually do when standing on the moon for the first time? A few hours later, Armstrong climbed down the ladder and placed a boot on the dusty surface. That's one small step for man, one giant leap for mankind. It was a short sentence, but it carried the weight of history. Buzz Aldrin followed. Together, they explored the moon for just over 2 hours. They collected rocks, took photographs, set up scientific instruments, and spoke with the world from a place no human had ever stood before. And yet, the most astonishing part may be what happened after the excitement faded. The Apollo 11 moon landing was not only a dramatic moment. It was proof that an enormous system of science and teamwork could work together at a level humanity had never seen before. The mission relied on physics, chemistry, computing, communication, materials, medicine, and human courage. Every part had to succeed. Some people still think the landing itself was the miracle. But the real miracle was the chain of thousands of small, exact decisions that made it possible. The evidence is everywhere. Moon rocks brought back by Apollo missions have been studied for decades. Tracking data, photographs, telemetry, and mission records all match the story. The landing site has also been photographed later by lunar orbiters, showing the equipment left behind. The achievement was real, documented, and witnessed by the world. So what changed history? Not just the fact that humans reached the moon. It was what that moment said about human ability. It showed that a species once bound to one planet could reach another world through skill, planning, and determination. It changed science, inspired new technology, and proved that goals once called impossible can become real. And perhaps that is why Apollo 11 still matters so much today. Because when Neil Armstrong stepped onto the moon, he was not only standing on lunar dust, he was standing on the edge of what humans can do when they decide to try. And once that happened, the moon was never just a dream in the sky again.